So as David said, I'm going to touch on some things that's going to feel a little bit like I'm teaching you to suck eggs, but I think it's good to go over and make sure everybody's on the same page. And for some newer faces in the room, maybe you'll learn something. But the very first thing we need to understand is to fly at VRA launches, you need to be a VRA member, and you need to be a Tripoli Rocketry Association member, which is of the US organization. So if you aren't a member at the moment, welcome. Welcome to the club. You know, if you are, then thanks for coming. The method for joining Tripoli and for renewing your the method for joining VRA and renewing your membership has changed recently, as David touched on at the start, a tidy HQ system. So if he didn't quite get you at the start, I'll try and get you now. Go and check it out if you've got the time. You'll get prompted to sign up eventually when it comes time to renew your membership, but it is quite full-featured and useful for us. So yeah, once again, only financial members of both organizations can fly at our launches. This is a requirement of CASA and for us to be insured. So when we fly, we have to comply with Tripoli safety code. And many people may not be familiar, but Tripoli have recently updated and unified their safety code and put it in a really accessible format on their website. It's historically been a little tricky to navigate and find, but these days quite accessible. If you just go to tripoli.org and find their safety page, they've actually zipped it all up nicely into a single handbook. And what we'd expect of our members that intend to fly at launches is that you are familiar with the safety code. It shouldn't be up to the RSO or the LCO to be pulling people up on kind of obvious safety code breaches. And that safe ethos is what allows us to happily fly rockets safely and without incident. So that's very important. We also notify CASA every time that we launch, and we are given a waiver by them to launch rockets with specific limitations on altitude, impulse, and the kinds of propellants that we can use. So just as a reminder, the Sparky propellants and barium propellants, we can't fly in Victoria. So I believe there'll be a few people down from New South Wales at our next Serpentine launch, which might not be a bad time to arrange I've already uploaded something. A transfer of propellant in some capacity. Bears thinking about. As I mentioned, you can find the safety code at the Tripoli website. Even if you've been around the traps for years, it always helps to brush up on and read. So when you attend the launch, I'm just going to go over personally what I do, I guess. What do I wear? What do I bring? What do I do at a launch? And what do we expect members to do, and what would we like members to do? Bring your rockets. It might be an obvious one. If you're not into launching, you don't have to bring a rocket to launch. But that's the first step. If you are going for certification, it's very important that you bring your universal certification form. Bring your proof of Tripoli Rocketry Association membership. I didn't get a screenshot, but these days you can actually download a digital copy of your Tripoli identification card, which will have your latest certification level on it. And you can keep that on your phone. And that way you can show the RSO or the LCO when we're doing a membership check at the start of the launch. If you've, for instance, recently you've recently certified to another level, for example. If you need some tables, if you need chairs, it's something that you don't always think about. If it's your first launch or your second or your third launch even, it's very useful to have a surface on which to launch if you're prepping rockets. Bring coins for the barbecue at Serpentine. We do have the square reader, but it has its moments. So bring a couple of gold coins, have a snag, have a drink, and bring a water bottle and a way to refill it. That's pretty critical. Things to wear, a hat is a great start. We have lovely VRA bucket hats available at a pretty low price, I believe. I would recommend wearing long sleeves and kind of durable clothes, particularly if you anticipate launching things that you're going to have to walk. It'll also keep the sun off you, keep you safe. Conversely, you should also think about bringing a jumper at Druin and at Serpentine, particularly through the mid-year launches. It can be very, very cold. You might not realize it, but particularly the early mornings can be frosty. And sturdy shoes are very important. You're out there in a paddock, trooping through the field. You don't want the mud coming in. Some common sense stuff. When we go out to launch, the equipment doesn't magically teleport into the middle of the field either. At both launch sites, we've got kind of equipment storage locations, and we need to move the equipment out to the site and set it up in a timely fashion and have the range ready. So our club is entirely run by volunteers. The committee are all volunteers, and you as flyers are all effectively volunteers. And what we would love is to see members coming a bit early. The range opens at 9 at Serpentine and 9 at Druin and 10 at Serpentine, but members of the committee are there from 8:30 a.m, if not earlier in a lot of cases, especially at Serpentine. And if we were to see a few more different faces, we can share the load a lot more effectively as a club. And that would be really great to see, especially with vehicles. That's one of the places we're starting to struggle at the moment. So if you can tow a trailer at Serpentine, we'd love to share the load on vehicles and moving equipment around. And similarly for pack down, we're all volunteers. We finish up at Serpentine at 4 p.m. And if you can give that extra half an hour to an hour to make sure everything's shipshape, that puts us in a great position to be able to unpack efficiently next time we go to launch. And it means that certain members of the committee are shouldering a quite heavy load. That's a bit of a typo. The flyers briefing and membership check-in. We've been trialing a new system, and I think it's been working quite well at the start of launches. So normally we conduct a flyers briefing. Very important that all attendees, flying or not, attend the flyers briefing and get the important safety information. The more people that are familiar with the safety code, and I'll throw you back to the safety code, the smoother we can make this. And if we can be quite confident that everyone around is above board on the safety code, then we can make the flyers briefing quite a quick and painless process. After that, what we're doing is a member check-in, and what we want anyone who intends to fly to do is to come and sign their waiver, give us the signed waiver, and show us your proof of TRA, Tripoli membership, and your certification level. In exchange, you'll get a wristband with your certification level written on it. And this way, the RSO can see every time you come to the RSO tent with a rocket, what your certification level is, and that you've signed the waiver and you're good to fly. It's a nice, easy system. We're open to suggestions if you could think of ways to make it better. But this way, we don't have to go shuffling through looking for your membership every time you come to the RSO tent with the rocket. Now, I'll touch a bit more on certification. Again, a lot of you will be familiar with this process, but essentially the way that we're allowed to fly and the way that we're insured as an organisation to fly is by offering training to our members and then allowing those trained members to operate motors of greater and greater impulse as their effective level of training increases. And so what the certification framework actually is about supporting flyers to be able to safely and effectively operate rockets. The certification process, kind of self-evidently gets more involved as you move from level 1, level 2 through to level 3. And it is a journey of gaining experience, gathering all those little bits of information from the people around you, and those more experience to build your own understanding. And it's not a sprint, which as university students, it's a careful balance for a lot of people in the room. You have to, you want to achieve a certain certification level to fly a certain rocket within the time frame that you have with the team, but we need you to also remember to 10 more launches, I guess, build that experience. It's really important to have that underpinning technical experience. So for level 1, very basically, you all know that motors H to I impulse are what this level covers. And to get your level 1 certification is a pretty simple process of building, assembling, flying, and safely recovering your rocket in a condition such that it could fly again if you were handed all consumables required to do so. And doing so with a TAP, a technical advisory panel member, or a prefect looking on. You need your universal certification form. I'm ramming that one home. And make sure the LCO will hopefully make sure your TAP is watching. If you want some more information on the L1 certification process, it's quite simple, but if you'd like some more, jump on tripoli.org. They have plenty of info. For level 2, there's an examination. Tripoli wants to see that you have gained some knowledge and you understand the underpinning physics behind what's happening, and have a good grasp of the safety code. And so while the exam is quite doable by anyone, I would encourage you to learn and know the questions, not to pass the exam, but to have the knowledge that the questions are trying to impart. That exam we can conduct at the launch site, but we would really love advance warning if you intend to sit an examination. And so you can email us or contact us via Tidy HQ to prepare us so we can have the exams ready. Jackson? No, so once you've passed the exam, you've passed the exam, but good question. If you do have any clarification points, feel free to bring them up in situ like that. I won't try and make you remember them until the end. Again, that universal certification form, you should all have a copy, and if you don't, you can find it on the Tripoli website. And once you've certified level 2, that also permits you to conduct research launches. I won't go too far into that, but just an important note for anyone who's thinking about moving in that direction. For level 3, large motors, expensive motors, and electronics. It's an expensive endeavor. It's a difficult endeavor, and it's really critical. This is the most dangerous stuff that we do. So it's really critical that this is the most professionally that we have to execute ourselves. To enter into this process, you need to find 2 technical advisory panel members who will support you through the process. And in order to find those people, you will need to be quite an experienced flyer. You will need to have demonstrated your experience using electronics and flying L2 motors and constructing L2 rockets successfully. There's a design process, there's a build process. It's quite the process. There's a whole flow chart on the Tripoli website that I didn't want to bring into the slides. It's quite a mess. And I'm sure that the website can answer questions more effectively than I can. So if you are interested in moving through to L3, it's definitely a worthwhile endeavor. But it's a difficult one. And I would suggest you thoroughly research it and consider whether you have the time commitment to offer to doing that, and the financial and the effort, the spirit to get into that position. And obviously you still have to fly and recover the rocket. And I can tell you, having been involved in launching a number of very large rockets, that is definitely probably the most stressful part. So I'm nearly to the end, but some good launch practices that we'd love to see. Come prepared. I'm terrible at this. So I'm telling you to do as I say and not as I do on this front. But if you can have your rocket basically ready to fly the night before, and you can arrive at 10 a.m, then you can have a very leisurely day. Please arrive at 8:30 and help us set the range up. But you know, effectively, you could be launching at 10 a.m. And if you have 5 rockets to launch and you launch them over a few hours, it's an awesome day out. And you don't have stress. You've already prepared them. You pull them out of the car, change the battery, whatever you need to do that last little step. It's much nicer than rushing. What we really need to see from rockets that are coming to the RSO, particularly ones that aren't kits, that are scratch designs, is some kind of simulation using OpenRocket or an equivalent program. And this is, David already touched on having an internal vetting process at universities, but this can be a really great way to gateway that internal vetting process that you do. If there's no open rocket for the rocket, effectively the rocket doesn't exist. If it's a kit, slightly different story, but we would really like to see simulations, much more simulations coming into the equation. If you've got unconventional design choices, unconventional construction techniques, we need to see, and the RSO really needs to see justification of how you think that they're going to work and work safely. And so that justification could be through some hand calculations or through some simulations, but they're going to need to be simulations that you can communicate effectively and validate, or through physical testing. And that's pretty important because whilst launching the rocket is physical testing, it's physical testing that comes with a high degree of risk. Whereas stepping on a cardboard tube, loading a cardboard tube effectively is a much safer way to de-risk testing that component for the first time. Yeah, people are fond of saying this as a bit of a throwaway, but it is rocket science. Do the science, get it right, do it safely. I already mentioned contacting us if you want to do an exam. If you're planning on launching something pretty high, if you are conducting a research launch or a static fire, or you have some kind of unconventional test. I know Monash HBR have a deployable payload in their past and maybe in their future, for example. Tell us about it beforehand, allow us to prepare and communicate and get that validation that we mentioned on the previous slide in advance, so you're not wasting your time on the range trying to give a 2-hour technical presentation to the RSO, for example. And of course, always follow the clubs and Tripoli's safety code, policies and practices, and the directions of the RSO and LCO. They're the bottom line on safety. And so please understand that any directions they give are with yours and the public's safety in mind. A little more on construction. Rockets that fly on different motors can experience very broad range of conditions. I mentioned earlier cardboard tube, and you might be comfortable flying a cardboard motor mount, for example, on a J200, I don't know, but probably not a H550, for example. So understand the load conditions that your rocket is going to be exposed to, and have a good think about your material choices based on all of the variables that are going into the behavior of your rocket. Sun construction is critical. It's critical across all ranges of rockets and all types of rockets, but as the thrust increases, so too does the likelihood and consequence of failure for your rocket. And very much so as the impulse increases and the altitudes we're reaching increases, the consequences commensurately go up. As a great baseline, cardboard, fiberglass, plywood are all fantastic ways to start thinking about designing a rocket. They're tested, proven, and an RSO is not going to sneeze at them when they come through the tent. So if you are designing from scratch, think about using materials that are going to be obviously sound to an RSO if you don't want to get held up in the tent. And just finally on construction, kits make a great starting point. I often feel as university students, we get quite offended at the prospect of being told how to make something, I guess, in a kit, and enthused by the idea of going our own way. And I've very much been that way. I don't think I've ever built a kit rocket myself, but I intend to start. They can offer a great platform to understand those construction techniques, particularly filleting fins, through the wall fin construction techniques, and all the basics that have underpinned the sport for a long time, a very long time. One very key point is to keep launch slugs at the forefront of your design and your construction. They should definitely not be an afterthought, and I've been caught by this before, but it's very frustrating personally as an engineer to be at the point where you have a complete product and then realize that you can't actually launch it safely because there's no way to make it stable until it's reached its velocity. The launch lugs are critical, and Melbourne have probably experienced this with their transition. We've definitely experienced it with our transition. They're not always the easiest things to implement either. And so having to go back and rework a design and remanufacture can be a tough pill to swallow when you could have built around them from the beginning. With 3D printed parts, we joke a little bit about it, but it is very critical to exercise caution using 3D printed parts. And when relying on their structural soundness, we need to test or in some other way be sure that they're safe or consider another material choice. Jeremy has a great photo, probably one of the best rocketry photos I've seen in his back catalogue with a 3D printed motor adapter. It can be really hard to judge the behavior of a material that's not necessarily, the material properties of the material aren't constrained only by its nature itself, but by the method of construction and by the way it's printed. And an RSO can't go back in time and look at you slicing the 3D print and look at the 3D printing and say, yes, I'm very familiar with 3D printers. I have that printer and I know that if I print something with these properties, it's going to be structurally sound in this direction to support this load. It can be a real unknown for an RSO. So if you've got some documentation and some testing of 3D printed parts, that's the best way to get them through an RSO check, I guess. But personally, and as a team at Monash, we generally try and move past printed parts as a rapid prototyping method, particularly for geometries, and then get the structural components, get something out of the machine room or out of a composite. When you come to the RSO, you need to have the center of pressure marked on your rocket. Think about this through the design process as well. And when you're simulating center of pressure, understand where it's being simulated at. It changes through the flight profile of the rocket. It can move, and depending on the velocity that your rocket leaves the rail, the center of pressure might not actually be where you think it is based on the default setting of whatever simulation program you're using. So that can be a trap for new players in that you have a rocket that's very stable once it's going quite fast, but if you're only on the 1.5 meter rail and you're going 15 meters a second as you leave the rail and the center of pressure's a bit further forward than you think it might be, you have that tilt over moment. So make sure it's marked on the rocket. And I didn't put it in the slides, but also make sure who you are and how to find you is marked on your rocket for anyone that might find it. We've had some awesome tales of rockets making their way back after months. And in a lot of cases, they have the name written loud and proud down the bottom. Hide it behind a fin if you don't want it in the photos, but make it clear who you are and how to contact you. Fins are the most important part of the rocket in our application. As sounding rocketeers, they are what keeps the rocket moving straight and not pointed at me. So I like them. They need to be solid. Through the wall mounting is always great if you can do it. Get some fillets on the inside if you can. It can be tough. Get some fillets on the outside. Please, as a personal favor to me, use tape and make them look nice. It'll also help the RSO feel confident in your fillets if you've done a spiffy job with tape and they look good, right? Even if they're not the beefiest fillets out there, if they look good, the RSO is going to be happy. And my best tip for getting rocketry construction experience outside of walking up to anyone in this room and asking, hey, how have you approached this problem before? They're not always available to you. They're not in your living room, but most people in this room have a computer and access to the internet. And there are thousands and thousands and thousands of awesome videos on YouTube, tutorials, blogs online, on even ozrocketry.com, I think, if you go back far enough. There are heaps of people who've done this before. Go and shamelessly steal their work. Our human kind of capability is built on the back of using other people's work and sharing our experiences and sharing our learning. And that's not more obvious anywhere else than at a university, I think. So utilize that. Do a lit review on how to fill it in, and that will help you. Will help the RSO really, and help us as a club have real confidence in the rockets that are coming through the club. Yeah, thank you very much. That's all I've really got. Any questions?
Thinks everyone's going to bring their rockets exactly how you've asked.
They'll be prepared on Saturday. Trevor.
So Isaac, what do you understand have been some of the more concerning things that RSOs have come across in recent launches?
And the biggest challenges I think have been around 3D printing, and it's a symptom of probably being so accessible. 3D printers are there, you can rapidly prototype, and you can easily make complex geometries. You can interface things that aren't always the easiest to interface by just printing it in the right shape. And so I think there's a place for that, and there's a use for that. But think about how you can move out of that prototyping phase. And often the joy and the frustration of rocketry is figuring out exactly how to make that tricky connection between 2 points, how to put the glue in, but also have the centering ring there and have the thing there. And yeah.
I will make the comment that 3D printing can actually be really good. It's a material like anything else. And if you design for the material properties, you actually end up with a very functional part. But it's not just a matter of, oh, I've got to join this to this. Yeah, that'll do it, bang.
It's also functional printing itself.
Absolutely. And
So
the material.
I've seen drilling years ago on nose cone, which beautifully printed, and it actually separated because it was cold and jointed.
Yeah, I've flown my nose cone probably a dozen times. No drama. I've flown transitions to Mac 1.0.
And
It's pretty much a cold they're more using an industrial, commercial, very expensive.
It's not an end of three.
Corporation as opposed to someone using a $200.
Yeah, I can still achieve the same thing on the PLA.
so a really good way to find some structural soundness in a 3D printed part, apart from testing it and designing specifically in the correct orientation for the loads you're going to experience, is to make it a composite. Put some epoxy on it, put some fiberglass on it even, give it a little bit of strength, and use the geometry that you've made and use another material to help shore it up.
If you're doing a transition, you can actually nest the tubes further together rather than have them completely joined with the gap filled by the 3D part. You can actually nestle the two tubes together and have the 3D form shape. That way the fiberglass tube.
Yeah, absolutely. So you can use prints, and probably should use prints in a lot of cases for aerodynamic surfaces where it's easier than making a complex composite shape. But the actual mechanical and structural interface happens on the inside. You can't see between the two tubes.
And I think where 3D printing really comes into its own is for jigs. Making jigs, thin alignment guides, or even molds. I think, in fact, mine's made molds.
Yeah, that's how our transition was molded internally on bolted together transitions. So yeah, perfect for mold making.
Drilling guide.
And drilling guides.
So it was a leading question because part of the reason why Isaac's done this presentation tonight is because there's been two things with recent launches that have been the greatest issue for RSO. One of them's been 3D printing. And so we're hearing that 3D printing can be good if it's done well and a range of factors, but there's been more instances in the last 12 months where we've had 3D printed parts presented in a rocket that really should have been just a model rocket, a C motor, D motor, something like that. So if you are going to 3D print, that's fine, but don't assume that it's necessarily up to scratch and it's going to get past the RSO. And the other issue, Isaac, would be your thoughts on launch slope or launch
Yeah,
rail guides.
I think we've, as university students in the room, I think most people can say they've been there and fought a battle with launch lugs in some capacity, whether it's not remembering them, whether it's needing to design them to stick out this far, whether it's just manufacturing them, attaching them. Think about them from the very start. When you do your requirements analysis for what you're making, the launch lugs there needs to be guided until it's moving fast enough to be stable. Make a launch tower, I don't know. But think about how you are getting from 0 to 20, 30 meters a second, because that's the crucial phase for achieving a safe flight.
So one of the issues is we've had some rockets come where the luggage has been screwed into a cardboard tube with no nut or anything on the back of it. Or they're ones that get glued onto the cardboard tube, which is okay, again, for model, for mid-powered rockets. But if you've got a 4-inch tube, bit of weight to it sitting on a launch rail, and there's a bit of wind that's moving around a bit, you know, we've seen those guys sort of come away. So it's not a bad idea to screw bolt those launch guides into the tube as well, rather than just having them glued on.
If you can get away with it.
If you
depending
get
on
away
the
with it, but the issue is the weight of the rocket. sitting
And-
on the rail. So it's not just about guiding, it's about it being able to sit on the rail while everything's happening, wind, other things. Also, yeah.
And so another trap for new players is doing an awesome paint job on your rocket before you're attaching your rail guides. And it's a low high power rocket, and then gluing your rail guides on without doing appropriate surface prep. And then you lose at the interface of the paint with the tube. So always think about sanding and how you're gluing if you are adhering. No, all right. I'll just echo what David said at the end about our internal review process at Monash. I think it's something that I'm proud to have left behind after my time as team lead. Is a process where we expect team members to tell us in advance if they're intending to go to a launch and if they're intending to fly. And then on the Wednesday before or the Wednesday the week before, we'll have a pre-flight review with that member. We'll check all of the things the RSO would check. We'll go a bit deeper if we can, and make sure that we're using our experience that we have as a collective, as a team. There's 100 people. Some of them have been around for 3.5 years, and know what they're looking at, and we can use that and help make that rocket as safe as it can be. And in that way, we make sure that the team member is prepared. They're not stressing their pants off and wasting 10 hours at a launch, or not 10 hours because we don't have that many hours in a launch. Sometimes it feels like it. But stressing for 5 hours at a launch, they're prepared already. The rocket's going to pass the RSO check, and it's a really good policy to adopt. I really thoroughly recommend implementing something like that for any rocket that a team member wants to launch. I know doubtlessly universities around the country have processes for vetting their team rockets, but it's the personal rockets that are going to slip through the cracks when it comes to, for instance, having a student-made flight computer detonate a charge on the table at launch preparation, which is what kicked us into action, right? I'm happy to own up to that. It wasn't mine, so I'm not putting myself out there. But a team member a number of years ago set off a powder charge on the table due to having built their own flight computer, and no one knew that they built his own flight computer. So have that review process, and you don't end up with egg on Monash's face. Pablo. our expectation when we have a pre-flight review for any rocket is that they bring it to us basically as they bring it to the RSO sans motor. And if it's not ready, then it doesn't pass the pre-flight review effectively. And also really nice if they bring us a flight card. Do your flight cards before coming to the launch. Save you 10 minutes.
Yeah, don't hesitate to grab a handful of flight cards, for future launch. We prefer you don't photocopy them because paper is factor and helps you. Grab the card ones that are at the launches and fill them out the brand if you want it.
Yeah, all right. I'll stop talking your ear off. Thank you very much. Hopefully we see, and I don't mean this as an attack, but as a hope for growth, an improved caliber of rockets showing up at launches and lots of successful flights, because that's what we love to see.
Thank you, Isaac.
Thanks, Steve.
Yeah.
Well, thanks everyone. That concludes the evening. It's been a long night, 2 and 3/4 hours, the presentations, but I found it very interesting. I hope you did as well. Hope you enjoyed the evening.